Hi, hello students. Welcome you all for my Abhyas education platform. This is Dr. Radha, your chemistry teacher. Welcome you once again. I have completed explanation part for solid state chemistry in my previous 5 sessions. Now, I want to prepare you people for NEET, JEE and CET. So for these competitive exams, from this chapter, what and all important questions will be asked. So that I am going to discuss. So entire chapter I am going to cover. You please participate more actively and you have to practice also. Okay? Okay, we'll not delay. We'll start. Okay, fine. Now, the very first question, see now I'm taking is, of course, multiple choice questions only, MCQs. Which of the following conditions favors the existence of substance in solid state? So for the solid state, for a substance to exist as a solid, so what and all conditions which are essential? See, you know very well, at high temperature, is it possible for a substance to exist as a solid? No, it is not possible for a substance to exist as a solid at high temperature. Because at high temperature, what is going to happen? Bonds between the constituent particles break up. So thereby, the individual constituents can move freely. So substance cannot exist as a solid at high temperature. So this answer is wrong. Okay. Then at low temperature, of course, when temperature is less, what is going to happen? Molecular vibration. So what is going to happen? It will be at their particular position only, but it will not move throughout the crystal. So what is going to happen? All the molecules are held very close to each other. Distance between the constituent particle is very less. So here low temperature is possible. Okay. So at low temperature, substance can exist in solid state. Fine. Then what about high thermal energy? When you give high thermal energy, again what is going to happen here? Mobility takes place. So this will also not holds good. Weak cohesive forces. If force of attraction is very weak, then constituents can move randomly. So this option also will not holds good. So from this, what is the conclusion you can tell now? Here, among all these conditions, which condition favors the existence of substance in the solid state means option 2, that is low temperature. Students, please don't get confused. So this is the correct answer for this question. I hope you understood, right? Okay, fine. Now I'm going to take up the next question now. What is the second question here? See, which of the following is not a characteristic of a crystalline solid? See, for that, you have to recall that explanation, what and all I have given for the crystalline solid. See, for the crystalline solid, definite and characteristic heat of fusion, of course, right? Isotropic in nature. So, will it show the same physical properties if you change the direction of measurement? No. Crystalline solid will show what? Different physical parametric values. Okay, when you change the direction of measurement. So what we call it as anisotropic, but here option given is what? Isotropic. So this is wrong. Okay, next, a regular periodically repeated pattern of arrangement of constituent particles in the entire crystal. Of course, crystalline solid means there will be regular pattern of arrangement will be there. So this is correct. Then crystalline solid is a true solid. Of course, it is a true solid, right? So these three holds good for crystalline solid. Then which one will not be the characteristic of a crystalline solid? See, these three are characteristic of a crystalline solid, of course. Then crystalline solids are isotropic in nature, like that it is given. This is wrong. So among these four options, now which of the following is not a characteristic of a crystalline solid means isotropic nature. So what is the answer for this? Here it is what? Isotropic nature. This is the correct answer for Which of the following is not a characteristic of a crystalline solid question? Students, so you have to remember all the characteristic of crystalline solid, amorphous solid, then only you can able to judge like this answer. Okay, fine. I hope you understood, right? Next. Now I'm going to take up the next question now. So what is the next question here? Which of the following is an amorphous solid? So which is the amorphous solid? What do you mean by amorphous? There is no regular arrangement in the what? Constituent particle. You please look at here, graphite. So actually in graphite, what is going to happen? So it is a highly what? Covalent crystalline solid. So this is not an amorphous solid, right? Graphite is not an amorphous solid. So this is not an amorphous. Then quartz, SiO2. So what is your answer? SiO2, silicon dioxide. See, silicon dioxide, actually what is going to happen to silicon dioxide? You know very well, in silicon dioxide what type of arrangement you are going to come across. Silicon is a tetravalent. So this silicon dioxide, because oxygen is present, it is highly electronegative. So what is going to happen actually? This silicon will loses what? Electrons. So it will gain what? Positive charge, right? So it will act as what? Amorphous solid. Silicon dioxide acts as what? Amorphous solid only. Then what about chrome alum? So chrome alum is not an amorphous solid. It is a perfect crystalline solid. Silicon carbide, again it is having a tetravalent covalent structure. So it is highly crystalline solid. So which is the amorphous solid? Means quartz. Glass is a amorphous solid. Because you know very well, when you heat, what is going to happen? Or else when you keep this glass particle for a long period of time, what is going to happen? There is a movement of atoms takes place. Okay, so that's what this quartz is a amorphous solid. I hope you understood now. So for this question, which of the following is an amorphous? Means quartz is a amorphous, whereas graphite, chrome alum and silicon carbide, they are not amorphous in nature. I hope you understood. Okay, fine. Now, the next question I'm going to take up. Which of the following arrangement shows schematic alignment of magnetic moment of antiferromagnetic substances? See, antiferromagnetic substances, you please look at here. What is the characteristic of antiferromagnetic substances? See here, their magnetic moment is what exactly? Domains move in opposite direction. Okay, so here orderly and in a opposite direction they move with each other. Thereby here net magnetic moment get cancelled, zero. So that is the characteristic of what? This antiferromagnetic substances. So actually this first one does not holds good for antiferromagnetic. So this is not the answer, right? So this is not the answer, and even this is also not, and this is also. Now what is the correct answer means? You please look at here. The domains are moving in what? Opposite direction. Okay. So the parallel domains are moving in opposite direction. Thereby the net magnetic moment get what? Cancel with each other. Such substances we call it as what? We call it as antiferromagnetic substances. So the correct answer is this one, fourth one for this question. Okay. Okay, fine. Now the next question. Which of the following is true about the value of refractive index of quartz? Okay, quartz or glass, like that I told, quartz glass. See, in the third question I told this quartz glass is an example for what? Amorphous solid, like that. So in amorphous solid, which property will come across? Refractive index is a physical parameter, physical property. So it remains the same even if you change the direction of measurement. What we call it as isotropic. So amorphous solids are what? Isotropic in nature. You know very well. So with that statement, what you can say here now? Because quartz is an amorphous solid, refractive index value, what is going to happen? Same in all direction, right? So this statement is correct now. What is that statement? Please look at here. Refractive index value same in all direction because amorphous solids exhibit what? Isotropy. Different in different direction, wrong. So that comes to what? Anisotropy. But amorphous solids are isotropic in nature, cannot be measured. This is also wrong. You can measure refractive index, always 0. This is also wrong. It is not 0. Okay. So for this question, what is the answer here? Which of the following is true about the value of refractive index of quartz glass means it remains same in all directions. So the first option is correct or true for this question. Okay, I hope you understood. Okay, fine. Okay, I am going to take up next question now. So what is the next question? See here, which of the following statement is not true about amorphous solid? Now I am discussing 6th MCQ. So these are all very, very important questions, students. Which of the following statement is not true about amorphous solid? See here, on heating they may become crystalline at certain temperature. Of course, this is correct. That is true. Next, they become crystalline on keeping for long time. Of course, that is also true. Amorphous solids can be molded by heating. Yes, correct. They are anisotropic in nature. This is wrong because amorphous solids are what? Isotropic in nature. So, which of the following statement is not true about amorphous solid means they are anisotropic in nature is not true about what? Amorphous solids. So, the correct option is option 4. So, this is the correct answer. Students, you please don't get confused. Go through the question properly. Understand the question. Then, each option you have to, what exactly you have to understand it. So, what answer is given? Whether it is matching to the above amorphous solid or not, just you think by recalling the properties of amorphous solid. Based on that, what is the judgment you can give? Because amorphous solids are isotropic, definitely this 4th option is not true. Okay? Fine. Now, the next option I am going to take up now. Here, the sharp melting point of crystalline solids is due to. Sharp melting point means what? At the same temperature, the entire solid get converted into what? Liquid. Because breaking of bonds between all the constituent particles takes place at a time. Thereby what is going to happen? At the same temperature, the entire crystal of solid get transferred into what? Liquid form. That we call it as sharp melting point. Yes or not? So here, the sharp melting point of crystalline solid is due to. Already I told crystalline solid means what? Regular arrangement. Long order arrangement. Right? So here, a regular arrangement of constituent particles observed over a short distance in the crystal lattice. Wrong. Because regular arrangement is observed for a long distance. Right? So this statement is wrong. A regular arrangement of constituent particles observed over a long distance in the crystal lattice. Yes, this is correct. Same arrangement of constituent particles in different directions. Pattern is not same. Okay, so this is wrong. Different arrangement of constituent particles in different direction. No, not like that. Actually, the arrangement of constituent particles in the different direction pattern only it is going to change. So, among this, what is the answer you can tell now here? A regular arrangement. This is not possible. Different arrangement is not there. So, these three are wrong with respect to what? Crystalline solid.